Hello everyone, my name is Juan Sebastian. I am a master student of civil engineering at the University of Maine under the supervision of Professor Aaron Gallant. Today I will talk about the lateral and torsional resistance of modified helical piles using a novel color vein. Mm, Helical piles are lightweight deep foundations elements that are screwed into the ground and efficiently generates geotechnical, compressive, and uplift resistance by mobilizing the shear strength of the soil adjacent to the helical plates that are welded to the helical pile shaft. They are installed using mechanical torque and axial force applied by a drive head. Installation is relative, non-intrusive, less cumbersome, and appreciably less expensive. Despite the widespread application of helical pipe support for bridges, communication towers, pipeline foundations, and offshore facilities industries in the United States, they have been used sparingly by states' Department of Transportation due to, in part, to the uncertainty on limited understanding of helicopiles under lateral and torsion loads. Uh, a novel curve vein was applied to overcome this limitation in collaboration with Hubble Power Systems. 54 full-scale lateral and torsional load tests were performed in instrumented helical piles. Figure 1 shows the instrument helical piles with the strain gauges, and Figure 2 shows the set of different color vein geometries. Um, the, the ambition is that helical piles modified with the color vein may be used to support lightweight transportation structures. So, okay. So the experimental procedure is torsion, shown in figure 2, and a lateral test frame were instrumented with pressure transducer, load cells, and string pods. Also, the helical pile were instrumented with 8 strain gauges along the shaft to measure bending strain. Measurements were obtained using a 16-channel data acquisition system using the software LabVIEW. LabVIEW contains a comprehensive set of tools to acquiring, analyzing, and displaying and storing data. So in the torsional test frame shows a 10 feet moment arm, shows two hydraulic cylinders. The capacity of these cylinders was 3,000 pound square inch. It's also We also use two load cells to measure the load of each hydraulic cylinder. Mm, so both monotonic and cyclic load tests were performed. During the cyclic test, 1,000 load cycles were imposed to investigate the potential degradation of geotechnical resistance. Loads were controlled by an hydraulic controller. It was a Tescom ER5K. Controller lets the user controls the pressure to a given set point, improving accuracy and repeatability. So the results, a total of 54 tests were performed using the 9 different sizes of color veins. The test matrix is composed by cyclic test and monotonic test. Also, we use two different load sequence. The load sequence was the first one was lateral followed by torsional load, and the other sequence was torsion followed by lateral loads. So relationships between load and lateral displacement is shown in the figure 3a. Shows that as we increase the collar vein diameter, the the load required to displace, for instance, 0.5 inches, we require more load to displace the pile with the collar vein at this distance. Figure the red line shows the pile without collar vein, so shows that the load sequence has no influence in this case. And the open symbols shows the results of the displacement when the lateral test was placed first, and the closed symbol shows the results when the torsion test was made first, and later we applied the lateral load. And same case with the torque and angle of twist relationships. To If we want to displace the same amount of angle, we want to rotate the pile with the same angle, we need more torque as we increase the collar vein diameter. So also we got bending profiles, deformation profiles that are not shown in the lateral test. And the future work is use all the field performance data to develop generalized models, the PY or T theta relationships, to predict the lateral and torsional capacity of the helical piles modified with collar vein technology. The acknowledgements are for the University of Maine, University of Rhode Island, and Hubble Power System for designing and manufacturing the test frame and the collar veins. Thank you everybody for your attention.